cycle time improved by 15% in the final 1,000 units.
Yes, the automated assembly sequence optimization clearly paid off.
The assembly sequence looks fully optimized.
Agreed. All systems green for production.
This telemetry spike here, it doesn't align with the pressure readings.
I see it. Cross-reference with the previous run's parameters.
As you can see on the main display, the exploded view of the chassis highlights the integration points where we saw the highest error rate during the last run.
Air quality metrics are holding steady at 99.9%.
The regeneration cycle completed successfully.
Verification complete. Have a good evening.
Thank you. See you tomorrow.
This bottleneck here is significantly impacting our cycle time.
The data confirms a 12% variance.
Rerouting the supply flow should resolve it.
All barriers on the eastern gantry are secure and logged.
Excellent. The laser calibration passed, but monitor the voltage on relay 7.
Look at this performance chart. The energy recovery system is underperforming by 5%. We trace that back.
The aluminum sample shows consistent tensile strength at 450 MPa.
That aligns with the projected stress load for the new chassis design.
This exploded view highlights the critical tolerances for the main power conduit. Ensure the connectors are fully seated before the next stage.
Check the reference number on this fixture here.
Scanning now. It matches the manifest.
This fluctuation here suggests an anomaly in the welding sequence.
Agreed. We should run a diagnostic on Unit 4 before the next shift.
The transient spike here correlates directly with the chassis fatigue.
Agreed. The redundancy protocol's activated too slowly. We need to tighten the response window.
Rerunning the thermal load sequence on Sector 4.
Acknowledged. We are seeing a 5% efficiency gain on the chassis welding.
The defect rate spiked here on the assembly line.
Yes, cycle time was impacted. We need to investigate the root cause.
The caliper reading is outside the acceptable range here.
Yes, the digital report flagged that batch immediately.
Tablet shows green across the board for this arm. Okay, I've logged the temperature reading here. It's stable.
Check the tolerances on this bracket. Looks good within specification.
Look at this wireframe data here on the A pillar.
It's within the acceptable threshold, but let's monitor the next scan. The coverage is flawless. We are good to proceed to the next stage.
Confirmed. The reflectivity is spot on.
Wheel assembly secure. Torque checks complete.
Final specs confirmed on the mirror assembly.
Slalom complete. Proceeding to the braking zone.
Copy that. Deceleration looks nominal.
All systems nominal. Ready for review, Supervisor.
Sign it off. The M12 authorization is complete. Release the vehicle.
Platform aligned, moving to Station 3.
Clear to proceed, all clear.
Attention all personnel. Bay 4 is now fully secured. Release for transport.
Carrier 1 is clear for departure. Route Alpha confirmed.
Roger that. Releasing Carrier 2 now.
The final carrier is clear of the threshold. Batch 3000 is complete.
Excellent work. Proceed with shutdown protocols.
All departure protocols are confirmed for the graphite batch.
Systems show green across the board.
We've passed the 2,500 mark. 85% complete.
And the quality control data remains consistent across the board.
Look at the vibration spike here at high speed.
And the corresponding heat signature on the carbon ceramics. That's a critical wear indicator.
Look at the thermal data here. If we reroute the cooling, we gain significant efficiency.
And the manufacturing cost stays within target.
Reviewing the last parameters here, everything is within tolerance.
Confirmed on my side. Proceed with the final signature.
Phase 3 tolerances are within the acceptable deviation range.
Good. The dark graphite finish adhesion shows no anomalies.
All systems nominal. Final lock initiated.
Confirmed on auxiliary.
Logistics sealed.